Lecture is on digital geographies. It is intended to introduce and to contextualize the reading. The reading here by Ash Kitchen and Leszczynski from 2018, Digital Turn, Digital Geographies. It's about a 17-page article and it's fairly dense, so I suggest, making a good hour of your time available to read and take notes on the article, to supplement that with this lecture as well, and then to do the reading comprehension quiz that is due by the end of the week. Um, and then you also have your uh, midterm paper due by the end of the week, and I hope that you were able to spend some time over break, thinking about what we talked about last week, reflecting on the stuff that you see in your own social media feeds, um, and kind of how that impacts you in a variety of different ways, how you sit with all that stuff that you see, um, and how you kind of make sense of it. It's a lot. Definitely, it was a lot for me personally to create a lecture about that. It's not something that I'm super comfortable or super familiar talking about publicly, though I'm trying to get better at that. And I'm much more comfortable talking about maps and stats and um, transportation networks, and things that are a little bit more like quantitative and material and infrastructure related than I am talking about these kind of bigger topics and these kind of more uh, intense things. If you are interested in learning more about kind of interrelated intersectionality between environment and human, and how to process these things that we witness and how to contextualize them within a broader context, both Geography 300 and Geography 301 are both great courses for uh, getting a better framework and a better kind of set of understanding about these big kind of global humanitarian, ecological, environmental, intersectional relationships. They're both taught by Dr. Laura Johnson. They're both online Upper Division Area D GE courses, and she is much more kind of articulate and has better conceptual frameworks for understanding these like big global issues of climate change and um, sustainability and resources and spatial and social and economic and political realities of the world. So I definitely recommend looking at either of these two courses if you're in need of an upper division area D course. Um, 300 is a DCG non-domestic, and 301 is a GE area D with a sustainability focus. So both of those are great courses, and I highly recommend both of them for sure. Okay, so this week's course, or this week's lecture, we're going to talk about digital geographies. We're going to talk about the digital turn in geography, what that means, how the digital turn has transformed specific geographic practices and scholarship, how that's transformed methodology and epistemology within geographic research. So methodology being like how we collect data, what are the different techniques we use to collect and analyze data to draw conclusions in a geographic framework. Epistemology being like how do we even know truth within the world? How do we understand how things function? How do we kind of approach even the process of forming questions so we can collect research about? That's our epistemology, and that's in a large part informed by the digital turn as well. We'll talk about how the digital turn has impacted geographic thought and perceptions of space, and talk a little bit about digital technologies in everyday life, kind of relating back to what we did at the beginning of the semester. So the digital turn in geography, if we think about the field of geography, that has traditionally been a very field-based, a very hands-on, and a very experiential discipline. Before the digital turn or the digitization of geographic methodologies, often the field of geography had descriptive and comparative analysis at the regional scale. So people would study, these broad geographic regions like the Andes or the Himalayas or something like that, and then come up with descriptive ways to discuss those in relation to other places, talk about people and culture and religion and practices and agrarian techniques and things like that, and compare those regions with each other as a way to kind of make sense of the world and to show how places are similar and how they're different from each other, and how culture is informed by the landscape at these different scales in these different regions, these different types of environment. So that was one type of geography, what's known as the regional focus. There was also the landscape focused, and the landscape focus was really more looking at um, measurements and observations and things like that from a smaller scale area, like a riverbed or a uh, mountainous region or a forest, something of that scale, and taking observations, taking measurements, collecting data about various processes and forms that existed within that particular landscape. So you would look at, how, uh, for instance, uh, the stream channel changed based on different flooding events or based on different types of um, wood debris that would be kind of introduced into the ecosystem through logging practices or through fires or through even beaver uh, practices, and how those various aspects of the landscape change the geometry and the form and the flow of the river. For instance, that'd be a landscape focus, and that was done, both with physical processes, but also urban and um, urban and human processes too. So in landscape focus, you can see like, oh, how are these different like housing units and these different like transportation networks changing the form and the process and the movement of people within a city, for instance. Um, so those are the two different focuses that were in the traditional geographic discipline. It was very fields based, it was very hands on, it was very kind of experiential. You'd go out to the field, you'd observe things, you'd take measurements, you would um, contemplate what you were seeing, you would interview people, things like that. And then, if we think about like what is like the popular notion of geography as a discipline, National Geographic probably being the most explicit of that kind of imagery of what the geographic pursuit would be, right? And this is definitely what you would consider a regional focus, National Geographic, where it'd say like, oh, here's this region, and we're going to show pictures and tell kind of anecdotes about culture and about practices and things like that as a way for people to understand, how that place differs from uh, Western culture. What is valued, what are practices, what are things like that. So that's kind of like a traditional popular image of geography is the National Geographic focus, right? We also have, when we think about this like kind of landscape view of geography, we'd say like, okay, we can look at this like city along the river. We can understand how different transportation, different aspects of the river interact with people that live in this community, how trade, how economics, how things like that operate on this like place. This is kind of a landscape view of a particular city that we might go and observe various aspects of that in order to kind of make a proclamation or do an analytical understanding of this particular location. And when we think about like the National Geographic view, just some more kind of explicit images of that um, from the Himalayan, from Tibet. And I bring these up because here at Cal Poly Humboldt, we used to have a recently retired professor who took students every year to Tibet, and he would, embark on this like kind of long romantic journey of showing students the different cultural and religious and natural sites within this kind of broad landscape, so students could get a sense of like the Tibetan experience in this 3 week field trip type of course, right? And from that, it was this very picturesque, this very romantic version of traveling and viewing the world. And that's like what a lot of people kind of view geography as. And there is certainly a place of that that type of geographic inquiry that still exists, though with the digital turn, as I'll talk about in a little bit, that's been de-emphasized a little bit based on the emphasis of technologies and measurement and quantitative sciences that have entered into the dominant geographic mindset. So there's some other images of a more traditional notion of geography, right? The Alexander von Humboldt map of different ecoregions as you go up the mountain. This is the namesake of our university, and a kind of depiction of different regions within this volcanic mountain in the Andes. And even, if we look at old maps of uh, land ownership and whatnot in Arcata and Eureka, this is from the Belcher Atlas, which is an atlas um, of Humboldt region for, I think, 1908. That's when it came out. So we can see, there's some geospatial and some analytical aspects to this, of looking at, different dimensions of space, different aspects of the terrain, how it's partitioned off and owned by different people, different forms that come from that, different relationships between the natural and the built environments within these kind of early maps. But there's still like a level of discovery associated with that, or a level of um, kind of detailing various aspects of the world in a descriptive and in a comparative way. Whereas with the digital turn, what we've done is we have increased our technological capacity for understanding the various aspects of the world. And whether that be through what's known as geographical information systems, or GIS, whether that be through the GPS, or the um, geographic positioning system that allows individual points to be located within a satellite constellation, and then those points can be mapped onto uh, a platform using a geographic information system to understand the distribution of various things, or even more emerging cutting edge techniques like using drones to take laser readouts called LiDAR of landscapes in order to pull out various kind of high resolution features. And so the digital turn, which really started with the proliferation of geographic information systems along with other computational systems in the late 80s, early 90s, has really kind of transformed geography from a discipline of inquiry about broad scale patterns, about descriptive analysis and comparative analysis, and field work and measurements and interviews and uh, things like that, right? That was kind of a slower process, a more hands-on process, and a more you go to the field to learn something process, to a process where we're measuring and calculating aspects of the landscape from a distance in order to answer questions in a more direct analytical process. Here's some other kind of technological uh, features of kind of contemporary geography. This is what's called an augmented reality sandbox. And in this case, you can take a sandbox and you can display a kind of terrain-based digital representation on top of that sandbox. And so then as you kind of build mounds and build different forms within the sand, then it displays a map-like representation on top of it. So it's kind of a combination of reality and this kind of augmented digital representational space that you can play with. We have one of these in the library here at Cal Poly Humboldt that some GIS students built a couple years ago, that I think has been modified a little bit since then. But they built this kind of early rendition of an augmented reality sandbox. And you can go, play with it at various times if there's different events at the library. They have it out on display. With that digital transformation in geography, the digital turn in geography, we've become much more precise and much more explicit in understanding the landscape of various types of events, and the process in which these different events have unfolded. And so if we look at this map of Pompeii, we can see that there is an understanding, a broader geographic understanding of Pompeii that existed from kind of the early excavation, the early visitation of the site, and understanding how the volcano worked and how it impacted that community at the time of the eruption. I guess that was 1780 BC, and you can go to Pompeii now, and you can see all these different kind of like preservations of the Roman life at that particular time. But we can also use like high-level geospatial analysis in order to calculate with a very kind of high precision, the different ranges, the different radiuses of destruction, the different kind of uh, the precision that goes along with that kind of understanding that you would get from going to a place and observing it. We can also model that in a very precise and very calculated way using different types of digital technologies. And with that transformation of understanding the landscape in observational and descriptive terms to more analytical and technical terms, we've come up with a whole bunch of different methodologies that allow us to understand, uh, that allow us to analyze the landscape and analyze the environment in different ways. And so this is just an example of some different geospatial models that look at how we're going to analyze hotspots within an urban space, right? We have different vector polygons. We convert those into points. We can do statistical analysis on those points. We can create different types of hotspot analysis based on the distribution of points. We could also do the same, in a vector or in a raster or grid-based format. So not to go into too much detail about GIS, if you're interested in GIS, I can discuss that at length for sure. But that process of taking the landscape, digitizing it, doing different forms of spatial and analytical functions on that to derive information is really the hallmark of the digital turn in geography. It's like we're moving away from going to places, from observing things, from talking to people, from making measurements, from discovering new things in the environment, and we're taking that method instead into a more computational, quantitative, analytical focus that's aided by geospatial information systems, GPS, and other forms of new technologies. And we can see this reflected even within the two majors that exist within the geography department at Cal Poly Humboldt. If you look at the traditional, we have two majors in geography. One is kind of the traditional geography, Bachelor of Arts in Geography, and the other is a Bachelor of Science in Geospatial Science and Technologies. Those are the two majors you can get within the geography program. And if you look at the traditional geography, the Bachelor of Arts version, you can see that the courses are, focused more on understanding kind of these broad human scale patterns, regional variations, whether that's Middle East or California, understanding kind of how politics impacts geographic distributions, etc. Migrations and Mosaics is a course about immigration and migration and how that changed the landscape of the United States over time, and how we can look at the landscape of the U.S. from a historical point of view and understand the movements of people across the landscape at different times. And then if you look at the physical environment courses, those are much more focused on weather and climate and biogeography and ecology. And so these topics that have a scientific underpinning, but also are looked at from this kind of more broad regional point of view. Whereas if you look at the geospatial science and technology degree that has that Bachelor of Science, that has much more mathematical and quantitative requirements, right? You have these geospatial concepts, trigonometry. You have some kind of broad understandings of human and physical geography, so like have an understanding of like what the landscape is that you're measuring and doing analysis on. But it's at an introductory level, and then your upper division courses are cartography, geospatial programming, remote sensing, mobile mapping, right? These more kind of high-level analytical, quantitative, digital practices of mapping and analyzing and collecting data. And so we can think about what that process entails. If this is, on one hand, a more kind of traditional set of methodologies for geographic field, we're going out to the forest and measuring things and getting kind of the experience of going through the forest and understanding what the biogeography is of the forest and the succession of trees and plants and vegetation with different types of events. This is one form of looking at the landscape, the natural landscape, the forest landscape in one way, right? And then another way that we can do so, the more digital way, is using LiDAR, which is that kind of laser range detection system to get a point cloud of features, so an XYZ cloud of like a million features that are derived from a laser rangefinder that's usually flown on a plane or a drone. And then from that, we can get this very detailed depiction of the same forest, right? After this landslide event here, we get this very kind of detailed picture of the forest canopy. And so, what is gained versus what is missed with this approach versus what is gained versus what is missed with this approach is always the question to keep in mind when you're talking about what is the digitization of a discipline. What are the benefits and what are the, not consequences, but what are the uh, repercussions of that digital turn, right? Whereas this can provide high level of measurement, but the process of doing so takes maybe a long time. But then you also, during that process, you experience all sorts of different things about the forest that can inform your broader, comprehensive, holistic understanding of what you're doing. Whereas here, you can get, in a very short amount of time, a very detailed, rich, a very highly complex, a very precise depiction of a whole forest ecosystem. But you also kind of lose something because you're not in the field itself, experiencing the forest, measuring it, taking notes, uh, reflecting on the process of what you're doing, etc. And so, not to say that one is better than the other, but they're just two different ways to study the same thing. And the digital turn has kind of introduced this more quantitative and precise and calculation based metric into the geographic discipline. And from this type of forest canopy depiction, we can make easy geospatial representations of things like forest canopy health. This is a metric in DVI, which is a forest. Basically, you're using like the reflective quality of the tree canopy to demonstrate the health of the forest through this normalized vegetation index. Right? And so you can look at before and after an event in a very quick time. You can fly your plane or your drone over the forest, collect a whole bunch of data from before, or have a baseline, and then after an event, and you can see like how that fire event or how that landslide event or how that disease event of like bark beetles within a forest ecosystem, for example, kind of transform the forest landscape. You can see that in a very highly detailed and very quick way. So that's how um, the digital turn, what the digital turn is, the transformation of the practice and scholarship, how that's changed our methodology and how we know things, right? Our methodologies have become more digitized, more computational, more valuing a high level of precision. But then our epistemology, how do we know the world, that kind of transforms with that as well, right? Then we begin to know the world through these kind of quantitative metrics, through these precise geospatial representations, and we get to know the world a little bit less through going to the forest and visiting it and kind of experiencing all the different aspects of the forest that would come along with measuring that environment in a more analog or a more material way. And so this has had a pretty profound impact on geographic thought and our overall perceptions of space. It's given us what's known as a more data-driven understanding of the world. And so our understanding of how things happen in the world are much more informed by data and quantitative analysis of that data as opposed to our own kind of experiences of the world itself. It's increased our capacity for spatial visualizations and communications. We have a much easier time, not only with the digital frameworks that allow us to make maps at a much higher rate and do geospatial information analysis and representation at a much higher rate, but then we also have a higher level of precision and a kind of a lower entry point of skills that are needed to make maps on a computer versus maps by hand, for instance. The digitization of geography has allowed for a higher capacity of real-time monitoring and prediction of different ecological and human processes, right? So we can measure uh, in real time, we can measure like the impacts of a fire on a forest, or we can in real time measure the impacts of a new stop on a public transportation route and see how that impacts the flow of people, for instance. Um, it also enables new forms of spatial interactions. And so, in this case, like we talked about this a little bit before in terms of our habits and our perceptions of space and time and how those are impacted by the digital devices that we use. Like our phone, for instance, has a GPS tracker built into it, and therefore that kind of changes how we interact with the spaces around us. When our spatial location is always kind of measured, then the world around us can kind of be formed based on that measurement being known by various entities. And then with the digital geographies, we have to also have to think about the digital divide, and that is the unequal representation of, or the unequal access to different digital technologies, and uh, how that divide is consistent with racial distributions, with economic distributions, with urban, rural distributions. So there's like in terms of when we think about the digital divide, there's a interesting way to think about how who has access to technology and who doesn't. And so if much of our understanding of the world is built upon technology, then those that have access to that technology have a different conception of the world than those that don't have access to that technology. And that's what's known as the digital divide. Um, yeah, so a little bit more. I mean, explicitly, the digital divide refers to the gap between individuals, households, businesses, and geographic areas at different socioeconomic levels with regard to their opportunity to access information and communication technologies. And if you think about in terms of geography, it's to access information and communication technologies in addition to geospatial technologies, both software and hardware. And if we look at a graph of the digital divide, we can see that it's actually shrinking quite a bit in the past. This is 2017 here, so in the past 7 years, this is in California explicitly. You know, in 2017, 70% of households were connected to the internet through a laptop, and 87 through smartphone. So there's this gap between, almost 20% gap between people that were connected via smartphone only versus had computational capacities as well. Gap is shrinking over time quite a bit, but we can still see that in 2023, that 12% of the population is not connected via desktop or laptop, and then 9% of the population is not connected at all to the internet. And that is distributed a little bit or correlated with income, household income, right? You have higher income, you have more capacity to have access, whether that's through cellular devices or through computers and broadband, right? And so we can see that once you kind of pass that $20,000 per year threshold, then your capacity to have access increases substantially. And this is geographically distributed as well. Different areas, I mean, this is tied to economics as well. Different parts of California have higher kind of baseline economics than other parts, for instance. But we can see, in different parts of California that different regions have different levels of access. So this is what, a visualization of the digital divide. And then if we look at this globally, right, we can see, what percentage of the population has access to the internet at different countries. The United States is somewhere around 80%. Other developed countries, Canada and Europe, is even higher. Australia, other countries, substantially lower. So that's when we talk about the digital divide. To think about, we have all these digital technologies that allow us to measure and understand the world in all these different ways. But in doing so, that capacity is not equally distributed across the state, across our communities, and across the world as a whole. And then finally, some of the challenges of the digital turn. As geography is increasingly a technical field, then there becomes a certain level of technological dependence and a skill gap that is built into that. Whereas it's pretty easy to train people to go out to the forests and to observe and to take measurements and to take notes and to do these kind of more observational and physical task of collecting data, where it's much more difficult to teach somebody how to use a laser-based rangefinder device and to transform that into a computational framework and then to do analysis on that, for instance, right? So the skill gap is quite a bit higher in order to learn these more technical skills. And then we also become kind of dependent on those skills for our understanding of the world. And then, as we talked about in other capacities, anytime you're using these kind of technologies to ascertain information about people or places, then there's always these privacy and ethical concerns that are associated with that. Some other challenges with the prioritization of geospatial, mathematical, and programming skills. We have a data quality and data accuracy conundrum that we encounter in geospatial data, is that it's really easy to make geospatial data. We can make a lot of it through any sort of geospatial field studies, data collection processes, etc. But actually assessing the quality and the accuracy of that data is very difficult. And that's what's known as a data overload. Oftentimes when we're going into these different geospatial database repositories, we can find a ton of data. Let's say we're doing a study on redwood forests, and we want to go in and look at different species distributions within redwood forests, and we're trying to go find some kind of basic data within that study area. We can go into different data repositories, and find tons of information about that particular study area, but then we have like an overload. We have to kind of go filter through that, figure out what is of high enough quality, what is high enough accuracy. Do we need to do some sort of formal accuracy assessment on that data before we can even do our analysis to ensure that it's accurate enough to derive good results from? Whenever we're using these kind of computational quantitative fields to do our study, then if there's an error in one set of data, that error can propagate through our entire project in really uncertain ways. And we can have kind of a cascading effect of error that kind of moves through our whole study. And by the end, the data that or the analysis that we've come to can be pretty flawed, because that one error that was within our initial data propagated itself through the project. And then, as we discussed, there's access and equity issues when we have such a prioritization on geospatial, mathematical, and programming and computational skills. And then simultaneously, there's been a de-emphasis on the experience, fieldwork, travel aspects of geography. We've seen this both within scholarship, as there's been a shift from qualitative to quantitative in a lot of ways. We also see this in the funding of universities and the funding of the development of scholars, whereas in the past there might have been more funding and more resources available for fieldwork opportunities, for taking students out to teach them techniques in the forest or at the beach or wherever we would do stuff around here. Now there's a little bit less emphasis, a little bit less opportunity for that, and a little bit more emphasis towards training people to be computationally proficient at different tasks. So there, that shift from qualitative to quantitative also comes with the kind of de-emphasis of some of those more outward aspects of geography that many people find appealing. And then from that, there's also been what's known as a homogenization of methodologies. So in this case, if we have more people that are trained to kind of do the same type of analytical work, and then it becomes like everybody's just kind of doing the same thing, and that kind of leads to a lack of creativity and ingenuity, because so many people are kind of doing the same type of research projects and using the same type of methods. So that's some of the challenges with the digital turn. So I hope that this lecture was informative and helped you kind of conceptualize and supplement what you learned in the reading. And the quiz on this material is due by Sunday. And then from here we'll move on to some more explicit geographic applications as it relates to artificial intelligence, environmental technologies, et cetera, et cetera. All right.